Hello, ladies and gentlemen, and welcome back. We're here looking at the 2004 Cayley contest paper. So that's the grade 10 level contest. If you're just joining us, we're on question number 24, so you can take a look at some of the previous videos. If you maybe just here for part C, or maybe you're here for the whole contest and you just clicked on 24, you can go back and search for the previous questions, all 23 of them. And of course, you can click the link in the description for a copy of the contest, and to go to the same website where the University of Waterloo hosts their solutions. And sometimes they and I differ. So let's take a look at question number 24 together, and we'll see what solutions we can come up with. All right, so 24. In the diagram shown, so this circle with a bunch of triangles, angle ABC is 90 degrees. Line CB and line ED are parallel. AB is equal to DF. AD is 24, so that's guessing the diameter. AE is 25, and O is the center of the circle. Yeah, so AD is definitely the diameter. Determine the perimeter of CBDF. Okay. So, we got some triangles here, and we know a relationship amongst them, and obviously we're told DA is a diameter, but we're not really given any information on F. I'm led to believe from the diagram that F lies on the circle, but they never make that clear. Is F the intersection point of AE, or is F some other? It looks like it. I'm going to assume it is, but I think they need to add a little bit more to the preamble of this question. Anyway, we got a diagram, we got some information about it. How about we fill it in? Let's get ourselves our pen and a brand new sheet of paper. And we'll draw ourselves a picture. You know what? That is a horrible, horrible circle, and I feel terrible for it. Let's see if we can do a little better. Still kind of oblong, but whatever, we'll roll with it. So DA, going to assume F is the intersection point here. And DF extends to meet ED, and we have a right angle here, and this is C and B, and we'll say this is O. Now we're told that DA is 24, and we're told that EA is 25. Okay. So some things we can note right away, and I'll write down my explanation in a moment. We can note that ED, that angle is right angled as well. The reason we can say this is because DE is parallel to CB. And so if CB cuts in at an angle at a right angle, ED should also cut in at a right angle. Another thing we can notice is that DO is 12 and OA is 12, because we're told that DA is 24 and it's clearly a diameter. So splitting it in half with the center means 12 on either side. Another thing I can see is that DFA is right angled. DO equals OA equals 12, which is a half of 24, which is the radius. 24 is the diameter. Now, how do I want to say this? If you have a point on a semicircle, which is what the top part of this is, so if you have a point on a circle subtended, so basically you just connect with. If you have a point on a circle and you connect it up with a diameter to make a triangle, that will always be a right angle triangle. And if you have a right angle triangle, then you can make a circle so that the hypotenuse is a diameter of the circle. So it's a useful circle geometry fact that if you have a diameter and you have a point and you connect it to either end of the diameter, you've made a right angle triangle. So that's pretty important. And so we also get that DFE is going to have to be a right angle triangle. Okay. Now, ED is perpendicular to DA. So EDA is right angled. So it's a right triangle. Therefore, EA squared, so the hypotenuse is the same as DA squared plus ED squared, so this is just the Pythagorean theorem. 25 squared equals 24 squared, and this will be equal to 7 squared. 7, 24, 25, that's a popular Pythagorean triple that comes up a lot on these contests. So if you doubt me, feel free to work it out on your own. But this is something that you can notice and makes your work go faster. Triangles like 7, 24, 25, or 8, 15, 17. These are good Pythagorean triples to know. So ED is equal to 7, and let's mark that in on our little diagram. Alright, now they share the same angle and they have the same right angle, so these two angles are going to be the same. And we can see that triangle EDA is similar to triangle CBA. Okay. And if we call this angle X, we see that we also get a little angle X in here. So we can also see that EDA is similar to EFD. Okay. So we get a bunch of similar triangles here, and I think we were told DF is equal to something. What is that equal to? Is that equal to AB or something? DF equals AB. Okay, so it's going to turn out that since this and this are the exact same, and they're similar triangles because similarity is transitive, so since DF is equal to BA, we see not only that those triangles are similar, but CBA is congruent to EFD. And so one consequence of that is CA is 7. Okay? We're trying to label some lengths here because what we're asked for is to compute the perimeter of FDBC. Okay? So we can slowly figure out, now I know that CE is going to be 25 minus 7, so 18. If I can figure out what EF is, then I'll know FC, and that's part of the perimeter that I'm trying to determine. Therefore, CA is equal to 7, because we already worked out that ED was equal to 7. Okay. Now, since they're similar, we know that ED to DA to EA is the same as, so that's CA, that'll be BA, and that'll be CB, and then we also have the same thing, but EF to FD to DE. And we know because of, we figured out this first, the bigger triangle is 25, 24, and 7. So now we know the ratios of all these guys. And we know what CA and DE are. We know they're both 7. So using that, we can figure out, well, what's CB? What's BA? What's EF? What's FD? So CB is 7 over 25, this ratio, times CA. And CA is 7, so we've got 49 over 25. In the exact same way, EF is also 49 over 25. And we can get BA is equal to FD is equal to 24 over 25 times CA, which is going to be, CA is 7, so we have 7 times 24, which escapes me for the moment. Calculator says it's 168. Oh yeah, days in the week. Silly me. 7 days, 24 hours in a day, so this is how many hours in a week. 168. Okay. Alright, so we now have a whole bunch of lengths here. So I don't want to keep flipping back and forth, so I'm just going to redraw my picture. A little smaller than before, but that's okay. All right. So what do we have now? We have 7 here. We have a 7 here. Now we have 49 over 25. 49 over 25. Now we have one of the length of the perimeter, and actually we have another one over here, 168 over 25. And we have BA is 168 over 25. And yeah. And we know this total distance, CF, is EA, which is 25, minus EF, minus CA. That's 25, minus 49 out of 25, minus 7. So that's 18 minus 49 over 25. So that looks like it'll be 401 over 25. Okay, so 401 over 25. Now we just need dB. Well, dB is dA minus BA. And that's 24. We were told that at the start of the question, minus BA, which is 168 over 25. So 600 minus 168, we're going to get 432 over 25. So the perimeter we're asked for, now that we have every single length in question, even though the diagram I have written is very small, we're asked for CBDF. Okay, so we have all those lengths, we just need to add them up. CB plus BD plus DF plus FC. Well, that's going to be, what's CB? That's 49 out of 25. Plus BD, we just figured that out. That's 432 out of 25. 432 out of 25. DF, I think we already knew that one. It's 168 out of 25. And then finally, FC is 401 out of 25. Okay. And when we work all that out, notice that 49 out of 25 and 401 out of 25, that's going to be 18. We already had that sort of pair already up there, and this one's also going to be 600 out of 25, so it'll be 24 plus 18, so I think it should be 42, but I'm actually going to do the calculation. So 49 out of 25, 432 out of 25, 168 out of 25, 401 out of 25, and we get 1,050 out of 25, which is equal to 42. So 42 should hopefully be one of our answers. There it is all by itself, C. So we bubble in C, and we're feeling good. We move on to question number 25, the last question on the Cayley paper, and we'll see that in the very next video. So thank you guys so much for watching, and I'll see you next time.